Laplace transformation and its applications. In this title, we are going to discuss finding the Laplace transform of some standard functions like step sequence, ramp sequence, impulse responses, and some waveform synthesis. Before discussing all these topics, first we will come to know about what is meant by Laplace transform, the definition of Laplace transform, and some standard properties of Laplace transform. Then we will move on to finding the Laplace transform for these standard waveforms. Okay. First, the conventional method of network analysis is time domain method. That one we know that the very conventional method of network analysis, analyzing the network, is time domain approach, time domain method. It is simple if network is defined by first order differential equation. But as of order of differential equation increases, the time domain method becomes complicated, tedious, and time consuming. So the Laplace transform method is very much suitable for obtaining solution of higher order differential equations. This method this method transforms the time domain equations into frequency domain using a complex frequency variable that is denoted as S equal to sigma plus j omega. Okay. Now it is a complex variable. Now we will see the definition of Laplace transform. The Laplace transform of a function. I am going to consider one function that is f of t. For if you are going to calculate Laplace transform for that function f of t, that is indicated as f of s. F of s, where f of is a what? It is the Laplace transform of the function f of t. Here I consider one function that is f of t. For this function, I calculated Laplace transform. Notation for representing Laplace transform is L. So that is represented as f of s. What is the definition? Integration over the limits minus infinity to plus infinity f of t multiplied by e to the power minus s into dt. Okay. So let us represent this as a equation 1. Now, where if f of t is defined as is defined for if f of t is defined for t is greater than or equal to 0 time. What it means? If f of t is defined for t is greater than or equal to 0, this indicates the function. The function f of t is causal function. Is called as, if f of t is present only for this time t is greater than or equal to 0, then the function f of t is called as causal function. If it is so, then if we calculate Laplace transform for this causal function, that is defined as, that is given as f of s equal to Laplace transform of f of t, that is equal to c. Here, as per the definition of Laplace transform, limits varies from lower limit is minus infinity, upper limit is plus infinity. So, but the time, the value of t present only for t is greater than or equal to 0. Hence, the limits becomes 0 to infinity. F of t, the remaining term as it is, f of t multiplied by e to the power minus st into dt. Let us represent as equation 2. Here s is the complex variable. Here s is the complex variable, and s equal to sigma plus j omega. The real part is sigma, is attenuation constant or damping factor, okay, and is a angular frequency. And is a angular frequency. Let us see some standard with the help of this definition. Let us calculate some simple numericals. We will observe some simple numericals. That is, first one, find the Laplace transform. Find the Laplace transform of the function f of t is equal to k, where the value of k is present, t is greater than or equal to 0, else it is 0. Where where k is constant, where k is constant. So it is the given numerical problem, and for this given function, we have to calculate a Laplace transform. So the function f of t is equal to k. It is a k is a constant term. It is present only for the duration t is greater than or equal to 0, else it is 0. Okay. So let us write the definition of Laplace transform. F of s equal to integration over limits 0 to infinity f of t e to the power minus st dt. Now substitute the given value, that is 0 to infinity, because this function is present for what t is greater than 0. Because of that reason I return 0 to infinity. F of t is what? F of t is k multiplied by e to the power minus st dt. Further simplification, k is a constant term, take it outside, integration 0 to infinity e to the power minus st dt. Integration of e to the power minus st, so that is 1. We are going to write it as k is constant outside, it becomes e to the power minus st, integration of e to the power minus st divided by minus s, limits are 0 and infinity. Okay, for the simplification, substitute the limits. K is constant as it is outside. First I will substitute upper limit, that is infinity, in place of t. In place of t, substitute the limit t, and e to the power minus infinity multiplied by s, of course, that is infinity, minus as it is, divided by minus s, minus of lower limit e to the power, in place of t 0, that is 0 multiplied by anything is 0, divided by minus s. Okay, next, for the simplification, k is constant as it is, e to the power infinity, that is 0, it becomes 0, this term becomes 0. Okay, minus into minus, it becomes plus, plus e to the power 0, that is 1, 1 by s. Hence what is the answer? We are getting the answer as k by s. So what we calculated? Laplace transform of function f of t, that is Laplace transform of function k, is what we got, k by s. This is our answer. So similarly, one more term I will take, one more function I will take, that is okay, in place of if k is a constant, for your understanding I am telling, if k equal to 1, then what is the Laplace transform? Laplace transform is what? 1 by s. If k equal to 10, what is the Laplace transform? 10 by s. So because k is a constant term, in place of k substitute the values, so we are going to get the value here. Okay, next, similarly, one more problem I am going to discuss. Find the Laplace transform, find the Laplace transform of the function f of t, where f of t is given, f of t equal to e to the power minus at for the time t is greater than or equal to 0. So this is the given problem. For this one, what is the solution? First I will write the given data. What is the given data? Given data is function. Given function is what? F of t equal to e to the power minus at for t is greater than or equal to 0. So I'm going to write the definition of Laplace transform. F of s is equal to Laplace transform of f of t is equal to integration over the limits, because this function is also present for the time t is greater than or equal to 0, hence limits becomes 0 to infinity e to the power minus at. Okay, because function is f of t is equal to what? E to the power minus at multiplied by e to the power minus st into dt. Okay, next observe the power terms here. E to the power minus at is there, e to the power minus st is there. I will take the common. So in the next step, uh, f of s is equal to Laplace transform of f of t is equal to. So what is next step? Limits remain same, 0 to infinity. I will take e to the power minus s minus t. I will take it common. In both the exponential terms, t is present. So I will take minus t outside. So what left? S plus a into t dt. So let us integrate this one. Integrate this one. So what is the answer? Integration over the limits 0 to infinity e to the power minus inside the bracket s plus a t divided by s plus a is a constant because denominator minus multiplied by s plus a. Okay, so I will substitute the limits infinity and 0, infinity and 0. Next, further simplification, upper limit first, e to the power t equal to infinity, infinity by multiplied by anything, it remains infinity minus infinity. Denominator is what? Minus s plus a minus e to the power t equal to 0. 0 multiplied by anything, it becomes 0 divided by minus s plus a. Okay, further simplification. So e to the power infinity, it becomes 0. 0 by anything is 0. So first term remains 0. Minus into minus plus e to the power 0 is 1 divided by s plus a. So what is the answer? Hence we got Laplace transform of the function e to the power minus at, e to the power minus at is equal to what we got? 1 divided by s plus a. Likewise, we are going to calculate the Laplace transform for the given